In section 2.2, we're working on multiplication of polynomials and multiplicative properties of exponents. We're going to get some properties of exponents in 2.2 and some more in the next couple of sections. First, we're going to multiply two binomials, then we're going to multiply two general polynomial functions, and then we're going to apply those properties of exponents. So, starting off, we've got a situation, we've got some kind of parking lot, and it has 2 rows with 6 parking spaces. So you can see our 2 rows with 6 spaces across the bottom here. So current number of spaces is 12. Fortunately, we're going to expand this lot, but we want to maintain the relative shape. So for every 4 cars added to a row, we're going to add another row. So if we start this situation by adding 1 row, we're going to add 4 spaces. So we want to figure out how many spaces we have. So in the original parking lot, there were 12 spaces. If I add 1 more row, that 1 more row to the original 6 spaces gave me 6 more spaces. Then I'm going to get 4 more spaces, and I had 2 rows here, so that would be 8 spaces. And then my 1 row with those 4 spaces would be 4 more spaces. So I can determine the total number of spaces 2 ways. One of them is the sum. So I'm going to have 12 spaces in the original lot, plus 6 spaces in that next row, plus 8 spaces in the first 2 rows with more spaces, and then 4 more, etc., in the last row with those new spaces. So if I add all of this up, this will be 30 spaces altogether. Now, we can also compute this by saying that 2 rows plus 1 row is 3 rows, 6 plus 4 spaces is 10 spaces, and 3 times 10 is 30 spaces. And wow, that was a lot easier to do than to do all those little sum pieces. However, I may not always be able to finish the multiplication if I have terms that are not like terms. I may have to keep them written in the addition form, which is what we're getting to for the polynomial examples. So let x represent the number of new rows added to the original parking lot. Okay, so the number of rows, there were 2 originally, plus we're going to add x new rows. So last time we had 1 new row, so 2 plus 1 was 3. Now we're going to have x new rows, so 2 plus x. Then the number of spaces. There were 6 spaces originally, and we're going to add 4 spaces per row. So if I had 1 row, it was 4 more spaces. If I have 2 rows, it'd be 8 more spaces. It's going to be 4 times the number of rows, or sorry, the number of, rows that we add on. 4 times the number of rows is going to be the number of new spaces. So 6 plus 4 times x. Okay. Starting with a geometric expression of the current parking lot, extend the parking lot by x rows. So originally, hold on. I should just make this a little grid. Originally, I had 2 rows and 6 spaces. Now I have plus x new rows and plus 4x new spaces. All right. The number of parking spaces in each row is a function of x. Write the number of parking spaces per row, s of x. Okay, so our s of x function is the number of parking spaces, so that is our 6 plus 4x, and our number of rows, that is our 2 plus x. We'd already determined those before, we're just putting them in function notation because they asked us to. And so the total number of parking spaces is going to be a product of the number of spaces and the number of rows. Don't simplify yet, we're going to get to the simplifying part in a little bit. So our t of x function is our s of x function times our n of x function, or it's going to be 6 plus 4x times 2 plus x. Okay, so we've created that product function where we're going to multiply those two functions together. We're going to simplify it soon, just not on this page. It happens to come on the next page. First, we're going to fill in the numeric component of this. So if I plug 2 into s of x, so 2 new rows, s of x is my 6 plus 4 times x. That's 6 plus 8, which is 14. If I have 5 new rows, then 4 times 5 is 20. That'll be 26 new spaces. If I have 8 new rows, then 4 times 8 is 32 plus 6 is going to be 38 new spaces. All right, 2 new rows plus the 2 already there is 4 new rows. 5 new rows plus the 2 already there is 7 new rows. 8 new rows plus the 2 already there is 10 new rows. And if we multiply those, 4 times 14 is 56. 26 times 7 is 6 times 7 is 42. 7 times 14, so 182. And then I didn't use a calculator, so feel free to check me on those. I know the bottom one, 38 times 10 is 380. All right. Now, we're going to do the multiplication with the geometric model on the next page. And as you can see here, we know that our 2 times 6 is 12. And our 2 times 4x, this will be 2 times 4, that'll be 8x. Then our x times 6 will be 6x spaces here. And our x times 4x, that'll be 4x squared. So the result of this product, t of x, will be 12 plus 8x plus 6x plus 4x squared, or 12 plus, those are like terms, so 14x plus 4x squared. Right. Now, oftentimes we don't want to write down the whole box to do the product each time, so instead we write it over on the side. We just do a double distribute. They're doing the double distribute here, but I think it works better to draw the arrows like they're showing here. I'm going to write it instead. So we do the 6 plus 4x times the 2 plus x. And when you do the double distribute for the product, you're just going to take 6 times both parts of the second parenthesis. Then you're going to follow up with 4x times both parts of the second parenthesis. So both items in the first parenthesis times both parts in the second parenthesis is your double distribute, your 4-part product. And so again, 6 times 2, that is 12. And then 6 times x, that is 6x. 4x times 2, that is 8x. And 4x times x, that is your 4x squared. So again, even if you're doing the double distribute versus the box product, you get the same thing. It doesn't really matter what order I had written the middle terms down in. I would still get the 12 plus 14x plus 4x squared, no matter which way I had done the distribute. We're going to use the double distribute most of the time here. It's just more efficient than having to write down the box, but if you prefer writing down the box for your product, you're welcome to do so. All right. There's some examples at the bottom of the page looking at multiplying some other stuff together. We're going to multiply some stuff here. We've got 7, or x plus 7 and x plus 5. Write the product. Okay. So I want to do f of x times g of x. That's going to be x plus 7 times x plus 5. And if we do our double distribute, first we would take x times x and x times 5. Then we're going to come back and we're going to take 7 times x and 7 times 5. So I'm going to write small because I'm going to have to combine like terms. So first, x times x is x squared. Then x times 5 is 5x. Then 7 times x is 7x. And 7 times 5 is 35. There we go. And then we combine like terms. We'll have x squared plus 5x and 7x are like terms. That gives us 12x plus 35. So that would be our simplified solution for that product function. Okay, so they are going to have us just check this with a table. So I need to get my Desmos graph over here. And I'm going to type in my two functions. F of x equals x plus 7. G of x equals x plus 5. And my product function, I'll check that one in a minute. So my table, let me start this with 0, 1, 2, 3, 4. I'm going to do the f of x function, f of x1, g of x1. And remember, I can just do the product right away as f of x1 times g of x1. And then I'm going to put, I'll just call it p for product. P of x, what we got as our result was x squared plus 12x plus 35. So if I do another column for that p of x1, oops, p of x here. That's why that didn't work. There we go. Then I'll be able to confirm that my solutions work. So using this kind of table is one way just to confirm that your answer is really your answer, that the product result matches with the product when you literally compute the product in the table of the first two functions. You can see that 7 times 5, that's 35, and I got 35 as a result from the product function as well. Okay, so I'm going to move this over and we can jot our values down here. In the original function, we had, when you plug in 0, we had 7. When you plug in 1, it was 8, 9, 10, and 11. And then 5, 6, 7, 8, 9. And for the product function, we got 35, 48, 63, 80, and 99. All right, so they want us to do some input values that are not in the table, so we can pick anything we want. I'm going to say -1, 8, -4, and 10. I'm just picking stuff. Plugging them into the original function. So into the original function, remember that f was x plus 7, so -1 plus 7, that's 6. 8 plus 7 is 15. -4 plus 7 is 3. 10 plus 7 is 17. And then for g of x, -1 plus 5 is 4, 8 plus 5 is 13, -4 plus 5 is 1, and 10 plus 5 is 15. So if I multiply these together, that should give me what my product function outputs. Now, we're also going to check this just by plugging these things into the product function. So I know the answer should be 24 for this one. Let's see if we get 24 when we plug -1 into the product function. The -1 squared plus 12 times -1 plus 35. I won't do this for all of them. We'll decimals do the rest of them. But this would be 1 minus 12 plus 35. That's 1 plus 35 is 36 minus 12, which is 24. So that's all just for the first one. So I don't have room to do them all by hand for sure, but that matches up because I get 24 as a result of plugging -1 into the product function, and I do get 24 if I multiply 6 times 4. So let's have Desmos help us with the others. I picked, so I picked -1, I picked 8, I picked -4, and I picked 10. So again, for the -8, 15 times 13 is 195, and you plug that into your product function, you get 195. So we're going to write in a 195 there. 3 times 1 is 3, and when you plug 3 into your product function, or -4 into your product function, you get 3. 17 times 15 is 255, and when you plug 10 into your product function, you also come out as 255. All right. Are the results consistent? Yes, they're the same. So it helps me check that my product function is correct. When you determine the product function, what do you multiply? Domain values, range values, or both? Well, I'm multiplying the outputs of the two functions, right? F of x times g of x takes the output. F of x is the output. X is the input. The two x's don't multiply. It's the outputs, the functions themselves that multiply. So it's the range values that multiply, right? So I don't need the x, the 10. these are the two numbers that I multiply, right? It's the two output values for the original function that multiplied to the output value of the product function. The two output values from the original functions multiply to give the output value for the product function. So just going to read what I wrote, but the output values f of x and g of x multiply to give the output of f times g of x. All right, we're going to multiply powers that have the same base now. So there's a new function down here. Hopefully they write it on the next page, because we're going to use it on the next page. But this function is v of r equals r squared times 2.1r plus 37.7. Hopefully we'll use this function in a moment on the next page. And they did write it down here again for me, thank goodness. So I want to determine the volume of the tank if the radius is 3 feet. So 3 is an input value. The radius was an input value here. So it's going to be 3 squared times 2.1 times 3 plus 37.7. And that sounds like something I should plug into decimals to get evaluated. Just going to type that in. I'm going to make a new one because there's a lot of table stuff going on over there. So never hurts to use parentheses. I'm going to do 3 squared times 2.1 times 3 plus 37.7. So altogether, we have 387 cubic feet, since that's volume. Okay, suppose we were asked to write this expression as an equivalent expression without parentheses. We'd have to use the distributive property. So the first product is r times 2.1r. So what is r squared times r? So they recall that r squared really is r. So r is r cubed. So when we multiply r squared times r, we get r cubed. There's already 2 of them. We get 1 more. You got 3 now. Okay. So now it's a matter of just verifying that. Oh, I'm sorry. My decimals is up there. Sorry, I was just pointing at stuff. They're going to try to verify that for us. Like, do you believe it? Do you believe that r squared times r is r cubed? So let's find out. 2 squared, that's 4, times 2 is 8. And 2 cubed is 8. So we're verifying that r squared times r and r cubed give the same value. 4 squared is 16 times 4. 16 times 4 is 64. And if you evaluate, just grab decimals, do 4 cubed, you're going to get 64 as well. So we're verifying that they're the same. 5 squared, that's 25 times 5. That is 125. And if you take 5 cubed, check it. What is 5 cubed? It should be 125. So again, we're just verifying that we get the same thing both ways. I can verify the last one on decimals just to show that 25 times 5 and 5 to the third power are the same value. They are. So 5 squared times 5 and 5 cubed equal each other. So how does the table demonstrate that r squared times r is equivalent to r cubed? So we can see that the outputs match. And so we can verify that we get the same answer if we're doing r squared times r versus r cubed. All right, so consider the following products. X times x to the fourth is x to the fifth. W to the second times w to the fifth is w to the seventh. A squared, a cubed, a to the fourth is a to the ninth. So here there's 1 and 4 more is 5. 2 and 5 make 7. 2, 3, 4, that's 2 and 3 is 5, and 4 more is 9. So it's the the exponent is the sum of the two parts of the product. Okay, so the resulting exponent is the sum of the two exponents in the product. That's what I observed. Now, when they write this down for us in the multiplication property of exponents, what they say is to multiply powers to the same base, keep the base, and add the exponents. So a to the m times a to the n is a to the m plus n. Add the powers. Okay. This is our first exponent rule. We're going to get lots more as we go through this section in the next. All right, so if I want to multiply x squared times x to the fourth, 2 and 4 more make x to the sixth. 2x to the third times x, I'm going to keep the coefficient 2. X to the third, 1 more x, I'm going to have x to the fourth. Adding 3 plus 1 is the exponents. There's that invisible exponent 1 right there. Negative 3 times 4, multiply those numbers, negative 12. Then when you get to the variables, x to the fifth, x squared, altogether 7x. 5 plus 2 is 7 and my power. Numbers multiply like regular. 5 times 3, that's 15. And when you multiply the variables, x to the fourth and x to the fourth make a total of x to the eighth. So we multiply the coefficients, add the powers, in order to multiply the variables. When you multiply the powers, add the exponents. Okay, so number 12, we're going to multiply these three together. So I would do the first two together. That would be 2 times 8, that is negative 16, a to the fifth, b to the third, and then we'll still times this by 3a squared b. So in the first two, they had different letters, so I couldn't combine the two letters together. I just collected all the a's and collected all the b's. Now we'll do the rest of it. I could do it all at once, but sometimes it's nicer just to break it down and do two at a time. The next one, negative 16 times 3. So that's going to give me negative 48 for the numeric product, the coefficient product. Then for my a's, I've got 5 here, 2 more there, so it's going to be a total of 7, 8 to the 7th. B, there's 3, 1 more, b to the 4th. 3 plus 1 is 4. Again, that invisible little 1 in the corner of that b. So negative 48, 8 to the 7th, b to the 4th. Oh, I already explained it. Okay. So find the product here. Okay. So f of x times g of x, I need to do 2x squared plus 3 times 5x to the third minus 2. So we're going to have to do, this is our binomials, so we're going to have to do our 4-part product. I'm going to take the 2x times both parts of the second quantity, and then I'm going to take the 3 times both parts of the second quantity. So my first step, when we do the 2x squared times the 5x cubed, 2 times 5 is 10, x squared, x cubed, 2 and 3 make x to the fifth. Then 2 times negative 2 will be negative 4, keep the x squared. Okay, that finishes the first part. Then we're going to start with that 3. 3 times 5 is 15, x to the third, none, x, 3x, still have 3, and then I'm going to have minus 6 as the last term from that 3 times the negative 2. Then we're going to combine like terms. Oh, nope, I don't have any like terms. So I am done, but I'm just going to reorder it because it's not in descending order. So I'm going to write the 10x to the fifth plus the 15x to the third minus the 4x squared minus the 6, so that it is in descending order. It's easiest to read a polynomial if it's in descending order so that you can not miss a term. So we have our degree 5, degree 3, degree 2, and degree 0 for the last term. Okay. When we get to the next one, we're going to multiply a binomial and a trinomial. So they want us to do it with the box and without the box and just see that we get the same thing. So with the box, we're going to take each part of the first times each part of the second. So we're going to start with a 4x, and we're going to multiply it by the x squared. That's going to give me 4x to the third. 1 and 1, 2 more is 3. 4 times negative 4 is negative 16. X and x is x squared. 4 and 3, that is 12, and x. Then 2 times everything. So that'll be 2x squared minus 2 times 4 is 8x plus 6. Then add up all of the like terms. So I'm going to have 4x cubed. There's no other x cubes. Negative 16x squared and 2x squared. That's going to be negative 14x squared. The 2 is positive. The 16 is negative. Then I'll have positive 12x and a negative 8x. That's going to be a positive 4x, and then the positive 6 at the end. Okay. If we were doing this without the box, let me start it over here on the side. I would have the 4x plus 2 times the x squared minus 4x plus 3. And I would take all parts of the first. So 4x times every part in the second times all 3 of these items. And then I would also take the 2 times all 3 of these items. Okay. So that will give me 4x times x squared. That's 4x to the third. 4x times negative 4, negative 16x squared. 4x times 3 plus 12x. That finishes the first. Then I would keep going with the next term, 2 times everything. So plus 2x squared minus 8x plus 6. And again, combining like terms. 4x to the third. I have to scan through to find my x squared terms. Negative 16x squared plus 2x squared is negative 14x squared. 12x minus 8x is a positive 4x, and then the positive 6 at the end. The answer should be the same. Again, organizationally, it doesn't matter which method you use. I don't typically like to draw myself a grid in a box, so I would prefer to maybe draw the arrows or just remember to take the first term times each in the second group, and vice versa. Same thing down here. The second item in the first parenthesis times each in the third. Each of the 3 in the second parenthesis, I should say. So organizationally, pick what you like. All right. Almost there. We got some special products. So we're going to multiply this guy together. We're going to start with the item that is first, x, times each of the items in the second parenthesis, and second item, which is 4, times each of the items in the second parenthesis. So that gives us x times x is x squared. X times negative 4 is negative 4x. 4 times x is positive 4x. 4 times negative 4 is negative 16. And what they would like us to observe here is when I combine like terms, negative 4x and positive 4x add to 0. So our result is x squared minus 16. So they're noticing that the inner 2 terms subtract out, and that's going to happen anytime you're multiplying binomial conjugates. Binomial conjugates are the same 2 terms with an opposite sign between them. If you got those binomial conjugates, then you have a difference of squares. Your middle 2 terms are going to subtract out, so you just have that squared terms at the beginning and the squared term at the end. Okay. So if I want to determine this product, I think it's best just to multiply it out. So if I want to do 2x plus 3 times 2x minus 3, then I get 2x times 2x is 4x squared minus 6x plus 6x minus 9. The 6x's cancel, so I get 4x squared minus 9. I think it's best to just multiply it out. They're trying to give me a shortcut. The problem with the shortcut is it only works in a very specific case that you're multiplying binomial conjugates. But the a value here is 2x. The b value here is 3. So a squared would be 2x squared, which is 4x squared, and b squared would be 3 squared, which is 9. So that would be 4x squared minus 9 a squared minus b squared as your answer. I think it's easier just to multiply it out than having to remember what to do in this specific case. Multiply it out like you always do, and you get your answer. You just have some things add to 0 in the middle, which is fine. All right. Multiply these two out, okay? So x times x is x squared. X times -4 is -4x. -4 times -4 is -4x. And -4 times -4 is 16. These are not opposites. They're going to add up. I'm going to have x squared minus 8x plus 16. What they want us to observe here, since these are identical, that if I'm squaring a binomial, multiplying it by itself, I'm going to end up with x squared. 2 times 4 is 8, so 2ab. 2 times 4 is 8. 2 times -4 is -8x. And then -4 squared is positive 16. So there's a formula for this as well. Again, I don't think that these formulas make it any easier. I think it's easier just to multiply it out and not have to remember a special formula and what case it applies to. So again, if I want to do 2x plus 3 squared, if I'm squaring a binomial, I need to multiply it by itself. Anytime you're squaring anything, it means to multiply it by itself. So 2x plus 3 times 2x plus 3, all four parts of your product here. 2x times 2x, that's 4x squared. 2x times 3 is 6x. 3 times 2x is 6x. And 3 times 3 is 9. So I can combine like terms to get 4x squared plus 12x plus 9. Identify A and B. All right, so A would have been 2x. B would have been 3, first term, last term. So A squared would have been 2x squared, which is 4x squared, and b squared would have been 3 squared, which is 9. So my answer should be a squared, so that's 4x squared, plus 2 times a times b, so 2 times 2x times 3, plus b squared, which is 9. So hang on, this is 4x squared plus 2 times 2x, that's 4x, 4 times 3, that's 12x, plus 9. I don't think this saves me any time at all. I think it's better to just multiply it out. It's fancy, but it doesn't save me much time. So do what you will. Okay. So use the identities to determine the following products. I would just multiply these out because I think it is better than remembering those funny things. So I'm going to do that anyway. X times x and x times 6, then 6 times x and 6 times -6. This gives me x squared minus 6x plus 6x minus 36. So altogether, x squared minus 36. Then I'm like, hey, yeah, I missed my middle two terms because I got a difference of squares. Check, check. Looks good. All right. Below, we're going to take the 4x times 4x, the 4x times -1, the 1 times 4x, and the 1 times -1. Okay. So 4x times 4x is 16x squared. 4 times -1 is -4x. 1 times 4, positive 4x. 1 times -1 is -1. Middle two terms are opposite, 16x squared minus 1. Middle two terms canceled. Binomial conjugates. Check, check. Okay. Squaring. Write it twice. So that's x minus 6 times x minus 6. So we're going to take x times x and x times -6. -6 times x and -6 times -6. X times x is x squared. X times -6 is -6x. -6 times x is -6x. And -6 times -6 is 36. Combine like terms. X squared minus 12x plus 36. And last, when you're squaring 3x plus 5, that's 3x plus 5 times 3x plus 5. Multiply the 3x times the 3x, the 3x times the 5. Multiply the 5 times the 3x, the 5 times the 5. That gives you 3 times 3 is 9. X times x is x squared. 3 times 5 is 15x. 5 times 3 is 15x. And 5 times 5 is 25. Combine like terms in the middle. 9x squared plus 15, that's 30x plus 25.